The first topic we'll start with today is learning about molecules and surface tension. Although we can't see it, everything is made up of molecules. For example, water is made up of water molecules. Molecules are so small that a single drop of water contains millions of billions of molecules. When the molecules in a substance are attracted to each other, this is called cohesion. And when molecules are attracted to dissimilar molecules, this is called adhesion. Now, let's hold on to that thought for a second there and let me ask you a question. Have you ever seen an insect standing or walking on water and wondered, wait, hold up, how's that happening? Well, this actually happens because of an effect called surface tension. Surface tension is an effect where the surface of a liquid is strong. The surface of a liquid can sometimes hold up a light weight. Some small objects can float on the surface of a liquid due to surface tension, even though they normally couldn't float. Surface tension is also the reason why some insects can walk on the surface of water. For example, insects called water striders use surface tension to walk on the surface of a pond or swamp. The surface of the water behaves like an elastic film, and the insect's feet cause indentations in the water's surface, increasing its surface area. The molecules at the surface of the water don't have any water molecules above them, so they bond even more strongly to the ones next to them and beneath them. Now, remember that new word I introduced earlier, cohesion? Well, surface tension is actually caused by cohesion, so in this case, the water molecules are attracted to each other. This extra strong cohesion at the surface of the water creates a kind of elastic film of high tension, and this is what allows some insects to walk on the surface of water. Cohesion is responsible for many of the behaviors of liquids. Water molecules have intermolecular forces called hydrogen bonds between them. The oxygen and hydrogen atoms are slightly attracted to each other in this cohesive force. And an intermolecular force is an electromagnetic force that acts between molecules. Now, we're going to take a break from molecules and surface tension and move on to our second topic of the day, which is forces and movement. Sir Isaac Newton was a famous scientist who was interested in many different topics, such as gravity, astronomy, and even the rules about how objects move. Newton created his 3 laws of motion, which are laws that affect everything that moves around you. There's a reason why things move the way they do, and it all has to do with force. A force is any push or pull on an object. Newton's 3rd law states that for every action or force in nature, there's an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B also exerts an equal force on object A. The forces are exerted on different objects. Now, at this point, we're actually going to pause here and get started with our hands-on activity. But I want you to keep in mind all of the concepts I just went over, and we'll come back to it later on. So, let's get started with making our soap-powered boat. For this activity, you will need a piece of cardboard. For example, you can use a tissue box or a juice carton, scissors, detergent or dish soap, and a tray or small tub of water. These items are optional, but you can also use a plastic bread tab, a toothpick, paper, and a hole puncher for this activity. First, you're going to fill your tray or small tub with water and keep it ready. Next, you're going to cut a rectangle out of your cardboard piece. Then, make cuts to the rectangle so that it's shaped like a boat. After that, draw and then cut out a notch or a channel shape into the back of the boat. If you're having trouble making the notch or channel shape, you can also try punching a hole near the end of the boat and then cutting a slit that reaches the hole. Once your boat is ready, you can place it in your tray or tub of water. Next, you can place a drop of detergent or soap in the notch or channel of the boat and watch your boat go. You can do this by either using your finger, a toothpick, or carefully pouring it from the bottle. Now, in order to make this a true experiment, we have to modify the variables that we test. A variable is something that changes or can be changed in an experiment. Some of the different types of variables you can test are: try using different liquids. Does the experiment work with soapy water? Does warm water work better than cold water? Does the type of liquid affect the boat's ability to propel forward? You can also try cutting out different shapes and sizes of boats, as well as different channel or notch shapes. You can test the boat without making a channel or notch and just putting the soap on the back of the boat. You can also try using a plastic bread tab. Does the shape and size of the boat affect its ability to move? Next, you can try using different materials to make the boat. Does it work better with regular paper versus cardboard? The next thing you can try is using different amounts of detergent. Does the amount of detergent affect the boat's ability to move? You can also try using hand soap instead of detergent or dish soap. Does the strength of the soap affect the boat's ability to move? And lastly, be sure to have fun with it and have boat races. Now that we've completed our experiment, let's get into the science behind it. Remember earlier on in the video when I told you to keep in mind the concepts I just went over and that we'll come back to it later on? Well, the movement of the soap-powered boat can be explained by a combination of 3 principles, 2 of which I went over earlier. The first principle is surface tension. As we went over earlier, all liquids have surface tension along the surface of the liquid, which are caused by intermolecular forces within the liquid, pulling the liquid molecules together. When you have a container full of water, the water molecules below the surface are pulled together equally in all directions, but those at the top are pulled together more tightly as they don't have any water molecules above them. This draws them together to create surface tension. Because of surface tension, liquid surfaces act like a kind of strong but flexible skin. In this experiment, the surface tension allowed the cardboard boat to float on top of the water. The second principle that explains the movement of the boat is Newton's third law of motion, which states that for every action there is an equal and opposite reaction. The movement of the detergent provides a pushing force backward into the water surface as the detergent molecules spread out, sending the boat forward. In other words, an equal and opposite motion. Now, the Marangoni effect also acted upon the boat. This effect describes how a liquid with high surface tension pulls more strongly on the surrounding liquid than a liquid with low surface tension. If you change the surface tension of some parts of the liquid, you introduce a difference in surface tension, or a gradient. The presence of a surface tension gradient will cause the liquid to move from areas of low surface tension to areas of high surface tension. In this case, the fluid from the soap region flowed towards the water region. There's fluid coming out of the back of the boat because of the net force between 2 liquids with different surface tensions. The fluid coming out of the back of the boat is what propels the boat forward. Now, soap is a surfactant, which means that it breaks down or reduces the surface tension and it weakens the hydrogen bonds of the water. As the soap molecules reduced the water's surface tension behind the boat, it created enough of a force to push the lightweight boat across the surface. The boat was pulled towards the areas of high surface tension by the water in front of the boat. So, as you might have learned from experience, to repeat the experiment, you probably had to get clean water without soap, so that the surface tension is equal throughout the water. And so, that pretty much sums up the science behind the experiment. So, to recap, what did we learn today? Well, we learned a lot. We learned about molecules, we investigated forces and movement as well as surface tension, and we got to apply what we learned by experimenting with the soap-powered boat we made. I hope you had fun making and racing your soap-powered boat today and you learned some cool new things.